Okay, now, a couple of questions remain. What if the cubic isn't depressed? What if you had a cubic that has the square term in it, like generally ax cubed plus bx squared plus cx plus d is 0? Cardano discovered how to approach this, and what he did was he depressed it. If it wasn't depressed, make it so. And his great discovery was how to do this, how to turn any cubic into a depressed cubic. He says you just make a substitution. You replace x by y minus b over 3a, where the a's and b's are the coefficients of your general cubic. So let me do an example of this. Let me show you how this works. Let's suppose I have this cubic, x cubed minus 15x squared plus 81x is 165. That is not depressed. The a is 1, the coefficient of x cubed. The b is negative 15. And so Cardano says let x equal y minus b over 3a. That is y minus negative 15 over 3 times 1. Well, minus 15 is 15. 15 over 3 is 5. So he says let x be y plus 5. When I go back to the cubic, I let x be y plus 5, stick it into x cubed minus 15x squared plus 81x equals 165, and you'll get, of course, y plus 5 cubed minus 15 times y plus 5 squared plus 81 times y plus 5 equals 165. You multiply all this out, collect the terms, and this turns into a depressed cubic. It always does. That's what Cardano showed. This always will have to happen. In fact, the depressed cubic it turns into is y cubed plus 6y is 10. That's the one we just did. I had x's in it, but now I got y's in it. I know what the solution is by the formula. Y is equal to the cube root of 5 plus the square root of 33 minus the cube root of negative 5 plus the square root of 33. But that's y. What's x? X is what I want. Well, look up above. X is y plus 5. So x, you just add 5 on, and there's your solution to the cubic, a solution by radicals. So even a non-depressed cubic can be solved via this process that Cardano discovered. All of this appears in chapter 11 of Ars Magna, the chapter he called Cubes and Roots Equal to Number. Okay, x cubed plus mx equal n. But remember, in those days, they had to avoid negatives. And so the example I just gave you that had a negative in it wouldn't have been legit in the 16th century. He had to do different chapters. Each chapter would handle cases in order to avoid negatives. There was over a dozen different chapters to handle all the different possibilities for the cubic that we can do in a single expression because we're not nervous about negatives. So the example I just showed you, x cubed minus 15x squared plus 81x equals 165 would not have been there. Rather, you'd have to look in chapter 18, which tells you how to do cube and roots equal to square and number, and sort of move this around a little bit, and you'll see that this could be reduced to x cubed plus 81x, cube and roots, bring the minus 15x squared over to the other side equals square and number. And in chapter 18, you'd see how to do that one. Well, Cardano's Ars Magna continues till chapter 39, where we find Ferrari's solution of the quartic. Remember, Ferrari had shown how to solve a fourth degree equation. And Cardano introduces this with this nice statement. He said, there is another rule more noble than the preceding. It is Ludovico Ferrari's, who gave it to me at my request. Through it, we have all the solutions for equations of the fourth power. So Ars Magna solves the fourth degree. How? He reduces it to a third degree. The third degree is reduced to a depressed cubic, and away we go. So everything gets reduced downward. It leaves one question hanging. What about the fifth degree? What about the quintic equation? ax to the fifth plus bx to the fourth plus cx cubed plus dx squared plus ex plus f equals 0. How do you do the fifth degree? I know what I'd guess. I'll bet you'd reduce the fifth degree to a fourth degree, the fourth degree to a third degree, and solve it that way. But nobody could. People tried this in the 16th century. The fifth degree was a roadblock. In the 17th, in the 18th, nobody could get anywhere until the question was answered by Niels Abel in the 19th century, a Norwegian mathematician who showed that the solution of a solution by radicals of the general quintic equation, fifth degree equation, or any higher degree equation is impossible. Can't be. There are no formulas for fifth degree or higher. It's a very strange turn of events. You can solve the cubic, you can solve the quartic. After that, algebra fails. And so I'll leave you with this thought that we sort of have verified the pessimism of Luca Pacioli. Remember, way back in the beginning of this story, Pacioli said you couldn't do a cubic. He was wrong. You could do the cubic. His pessimism was unfounded. You can do the quartic, but you can't do the quintic or any higher. At that point, algebra fails us.